Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilyas Bin Ismail, 4th year of student FKMP. Will present about my final year project 1, which is water spray system as reducing negative effects of welding emissions. For the chapter 1, I will explain about background of study. It has been conducted to reducing the toxic fumes using water spray system in local exhaust ventilation. Water spray system is one of technology where it can helps to keep local exhaust ventilation system clean the fumes before discarded to the environment. Water spray will cause the welding emissions to cool and coagulate, forming larger globule that easier to remove and clean from the filter unit. The studies of the different fluid pressure being analyzed to the water spray nozzle and produce finer particles that are coagulate with toxin fuel. As you can see on the right slide, it shows the schematic of diagram of water spray system. Next, for the problem statement, the nozzle that produce small droplets are more efficient because of their larger total surface area available for extraction of welding fumes. Besides, the effectiveness of water spray will be analyzed based on the different fluid pressure applied to the spray nozzle. For the objective of study is to conduct simulation of water spray based on the effects of applying different liquid pressure by using computational fluid dynamics. I have 5 scope of study. First, this research will focus on the simulation which to investigate the droplet size distribution and liquid pressure applied to the water spray nozzle. The water spray simulation based on a specific type of spray nozzles. For this research, deflected flat spray nozzle was chosen because of its characteristic, which is have very wide spray with low impact. And since fluent fluid flow as the CFD software that I use, the water spray pattern based on the different liquid pressure applied to the water spray nozzles. And lastly, the analysis of liquid pressure inside the water spray nozzle that can lead to final atomization. For the significance of study, poor air ventilation can harmful to human health. This research study is expected to provide information about an air cleaner with water spray in it and the effects of water spray based on the different fluid pressure applied to the nozzles. With water spray, a lot of small drops of water being thrown into the air to extract the welding chemicals. Next, move on to the chapter 2. I will explain about LEV, welding, mispray, and spray droplet size. For the LEV, it consists of 4 basic elements such as hoods, duct system, air cleaner, and fan. The figure on the right, as you can see, it shows the component of LEV. For my research, I will focus on the air cleaner. LEV will extract the contaminants such as dust, ash, mist, aerosol, vapor, and gas. For the welding, the fumes contain gaseous pollutant particles such as carbon dioxide, carbon monoxide, nitrogen oxide, sulfur dioxide, and ozone. If the welder inhale these welding fumes, it may harm human health such as cause lung damage and several types of cancer. Next, for the mist spray, it can be put in air cleaner to thinning all the smoke and particulate matters produced during welding process. The figure at the right shows the size of water mist based on the pressure applied, and the figure at the left bottom shows the common spray pattern from the flat spray, full cone spray, and hollow cone spray. Move on to the next slide, which is spray droplet size. As usually, nozzle spray pattern is made up of numerous spray droplets of varying size. The large droplets have the less drift potential because they are heavier, evaporate slower, and less affected by the wind. For the small droplet, often from high spray pressure, small nozzle tips or orifice, and wind shear across the nozzle. The table shows the droplet size classification chart by Griso on 2019. Next, move on to the methodology in chapter 3. This is my flowchart. The flowchart shows the process from the beginning to the end of the study. This is the design of deflected flat spray nozzle. From the sketch on the lower right of this slide, the deflected spray nozzle will design in SolidWorks and then imported it into ANSYS Fluent for meshing process. Next, I will explain about meshing. This is the figures of meshing of the deflected spray nozzle model. The meshing can be made into coarse, medium, or fine meshes. The finer the meshing process, the more accurate the results. On the right slide, the table shows the example data of the generated mesh that I have tried on my nozzles and the meshmatic spectrum. The parameter and the boundary condition is yet to be confirmed with my supervisor. Next, for the chapter 4, which is sustainability, the example impact of engineering solution is by performing simulations, unnecessary material waste can be reduced to zero. The solution method will be relevant in the future because of, as you can see, this pandemic COVID-19, so we cannot make experiment in university. For improvement of quality of life, water spray system will reducing the toxin fume before release it to the environment. Thus, the development of the study does not pose any harm to the environment. Okay, I think that's all from me. Thank you.